Welcome to this lesson once again. I am teacher Katimbo Richard, teaching mathematics. In the previous lesson, actually 2 sessions, we looked at a topic known as length, mass, and capacity, and we so much looked at the length, and so are we continuing the same. So on the side of the length, today we are looking at circumference, how applicable circumference is in one's life at school and thereafter. So the heading of our case study today is application of circumference. As we said before, circumference is the total distance around any circular object. And so, are we going to apply the circumference to see how useful it can be in our daily lives? So the example today, or the first example today, reads, a twin car tire 70 centimeters in diameter makes 30,000 revolutions from Kampala to Masaka. A twin car tire 70 centimeters in diameter makes 30,000 revolutions from Kampala to Masaka. Then the question, find the distance between Kampala and Masaka in kilometers, taking pi as 22 out of 7. Here, the key word to note is revolutions. The word revolution is an abstract noun from the verb to revolve. To revolve is to rotate or to turn. So the car tire being circular, it rotates for one to move from one place to another. In so doing, one will be applying circumference in one's life. So had it not been circumference, one wouldn't be able to move within his car. Why? The car tires wouldn't be circular. They are circular for easy rotation, or for easy movement, or for easy making of the turns. In so doing, one moves from one place to another using circumference. So by learning circumference here, you will be able to move in your car. Thereafter, thereby applying the circumference you learned at school. As the question suggests, find the distance between Kampala and Masaka. Now that the car tire is circular, we start. We say, one revolution represents circumference. When the car tire rotates, it will have made a circumference. And we know circumference given diameter is given by the formula pi d, which d means diameter, and pi has been given to be constant as 22 out of 7. So you expand pi d and say circumference is equal to pi times d. Circumference is equal to 22 out of 7 times the diameter of that tire, which is 70 centimeters. Now we are free to divide. The common divisor here is 7. 7 divided by 7 is the 1. And 70 divided by 7 is the 10. Thereby remaining with 22 times 10 centimeters. So circumference is 220 centimeters. And we have learned that this car tire makes 30,000 revolutions between Kampala and Masaka. And we already stated that one revolution represents circumference. And now the circumference is 220 centimeters. So in one revolution, that car tire makes a 220 centimeter distance on the ground. What about 30,000 revolutions? That is 30,000 times 220 centimeters, whereby 3 times 22 plus 66, and you write all the zeros that are 1, 2, 3, 4, 5 onto 66, thereby getting 6,600,000 centimeters. But the question went on telling us, it asked us for the distance between Kampala and Masaka in kilometers. Now that we have got it in centimeters, we are going to convert the got 6,600,000 centimeter distance between Kampala and Masaka to kilometers by stating KHDM DCM, which we can memorize as King Henry's daughter Mary drank cold milk. King Henry's daughter Mary drank cold milk. And somebody that is accustomed to drinking marwa can also say, King Henry's daughter Mary drank cold marwa. So that this is a kilometer, hectometer, decameter, meter, decimeter, centimeter, and meter. Our concern is centimeter as well as a kilometer. So write 1 against a kilometer, then write zeros up to the centimeter. In that way, you will have developed a fact that 100,000 centimeters make a kilometer. Now convert, having developed that fact, from centimeters to kilometers by stating the fact you have developed from the King Henry's daughter Mary drank cold milk, that 100,000 centimeters are equal to 1 kilometer. What about the distance we have got in centimeters, which is 6,600,000 centimeter distance? That will be equivalent to 6,600,000 divided by the fact which is 100,000. Answer in kilometers, then you divide. So we go on cancelling off the zeros, and whatever you're dividing, cancelling off the zeros, you're actually dividing by 10. You say by 10 by 10, 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 thereby remaining with a 66-kilometer journey between the said cities of Kampala and Masaka. So do you conclude that therefore 66 kilometers is the distance between Kampala and Masaka? In that way, you'll be able to know the distance between Kampala and Masaka using the revolutions as well as a measure in terms of diameter of your car tire. So you have applied circumference in life. Then example number 2 reads, how many revolutions will a bicycle wheel, 35 centimeters in diameter, make to cover a distance of 8.8 kilometers? Question reads, how many revolutions will a bicycle wheel, 35 centimeters in diameter, make to cover a distance of 8.8 kilometers? Take pi as 22 out of 7. As one can notice from their bicycle they have at home, it rotates like this. The moment it makes one revolution or one rotation, it will have made what's called circumference. You see it's rotating. Why does it rotate? Because the shape it is designed. So it's actually circular for easy rotation or for easy making of revolutions. A car tire or any tire, it can also be a tire for a motorcycle, tire for a bicycle like this one is able to move because of that circumference. I know you enjoy the ride at home, That enjoyment is enjoyment of circumference. So that is the use of circumference on this bicycle and your life and in terms of movement. Now, this bicycle tire, as I've seen, does revolve. It revolves. In so doing, it makes you move from one place to another, and thereby enjoying the ride. And now, they're asking us for the number of revolutions, for the number of rotations. Now, number of revolutions can be got by the formula distance divided by circumference. Distance divided by circumference, which distance has been dictated as 8.8 kilometers and which circumference you don't have. Because you have a distance and circumference not available, we shall not lament. We know how to get the circumference. That's what you say. But circumference equals pi d. Circumference equals pi times d. Circumference equals 22 out of 7 times the 35 centimeter diameter. So do we divide by 7 once? 35 divided by 75. Thereby remaining with 22 times 5. You side work 22 times 5, 5 times 2 is a 10, regroup 1, and say 5 times 2, see a 10 plus 1 regrouped, and get 11. So that is circumference called 110 centimeters. Now, distance has been given in kilometers. We cannot go ahead to divide unless there's an agreement between the circumference units as well as distance given. So kilometers and centimeters, when compared, a kilometer is far bigger or greater. So convert the greater to a less. And therefore, we still say King Girl's daughter Mary drank old milk, which means kilometers, hectometers, decameters, meters, decimeters, centimeters, and meters. And millimeters. So our concern are kilometers and centimeters. So write 1 at kilometer and write the zeros up to centimeters, thereby invoking a fact that 1 kilometer is equivalent to 100,000 centimeters. So it's easy here. You state easily from what you have invoked. You say kilometers to centimeters. As we have seen above, 1 kilometer is equal to 100,000 centimeters. What about the 8.8 kilometer journey, or the 8.8 kilometer ride on this bicycle? It's got 8.8 times the fact 100,000 centimeters. So you go 8.8 kilometers, you see only one decimal place. You have at 8.8, you write 88 out of 10, then times the 100,000 then centimeters. Divide by 10, divide by 10. You remain with 88 times 10,000, thereby getting 880,000 centimeters. 880,000 centimeters. Now that both the circumference and distance are in agreement in terms of centimeters, then you can proceed on to find the number of revolutions which we said found by dividing distance by the circumference. Circumference is 110 and the distance in centimeters 880,000 centimeters. So say number of revolutions is equal to the distance which is in centimeters divided by the circumference in centimeters. That's 880,000 divided by 110, divide by 10 by 10. 11 divided by 11 is 1. 88 divided by 11 is 8. 0 divided by 11 is 0. And so on. The other two zeros, thereby making 8,000 rotations, also known as revolutions. So one can tell how many revolutions his bicycle tire will make before actually moving to a particular place, so long as one knows the distance and one can actually measure the diameter of one's bicycle tire. In so doing, you will know how many times the car tire or the bicycle tire will rotate, and thereby applying circumference knowledge to one's life. Then we shall proceed to example number 3 for today. Having looked at the first two examples, we have the third example for today about application of circumference, and it reads, a car tire makes 4,000 revolutions to cover a distance of 4.4 kilometers. A car tire makes 4,000 revolutions to cover a distance of 4.4 kilometers. The question is, find the diameter of this tire in centimeters. Find the diameter of this tire in centimeters. Take pi as 3 1/7. Take pi as 3 1/7. Now, given a number like this, you look at the instructions. You have been instructed to find the diameter in centimeters, whereas the distance has been given in kilometers. In that way, directly convert kilometers to centimeters before anything is done. By doing the same King Henry's daughter made back called Marwa, write 1 against kilometers and write the zeros up to centimeter, convert kilometers to centimeters and say 1 kilometer is equal to 100 centimeters, 4.4 kilometers is 4.4 or 45 out of 10 times 100,000 centimeters divided by 10 by 10, we make 44 times 10,000, which is 440,000 centimeter journey. Now, we know a revolution means distance around this car tire, which distance around the car tire being circular is called circumference. So you say or state or relate the word revolution to circumference to go mathematical. Say 1 revolution represents circumference, meaning the moment I get journey or the journey done in 1 revolution, I'll baptize it circumference. But you have read the question telling you that the entire 4.4 kilometer journey was covered in 4,000 revolutions. That's why you say 4,000 revolutions represent the entire journey of 440,000 centimeters, which we converted from 4.4. What about the journey done in 1 revolution? That's 440,000 divided by 4,000 centimeters. Cancel by 10 by 10 by 10 by 10 by 10 by 10. Thereby remaining with 440 divided by 4. So say 4 divided by 4, 1. 4 divided by 4, 1. And here 1. And then this 0 remained. So in 1 revolution, it covers a journey of 110 centimeters. But you're already told the examiner, the moment I get a journey made in 1 revolution, I will name it circumference. Given that 1 revolution does a journey of 110 centimeters, therefore, so circumference is 110 centimeters. The new question reads, find the diameter of any circular object with circumference 110 centimeters. Then apply circumference. You say pi d equals circumference. Pi times d equals circumference. Use the dictated pi as 3 1/7. You say 3 1/7 times diameter equals the circumference, which is 110 centimeters. Now, convert to an improper fraction from the mixed one by multiplying the denominator by the whole number plus numerator out of denominator. Denominator times whole number plus numerator out of denominator. So 7 times 3 get 21 plus 1 get 22 out of 7. So 22 out of 7 times diameter equals 110 centimeters. So 22 and d are both numerators, so can they simplify? 22 times d is 22d. Now out of 7 equals 110 centimeters. We shall identify the parties. This is the party, this is the sign, this is the party. So I've got just the two-party equation whose LCM is 7. That's the LCM of 7 and 1. Remember, this is out of 1. So LCM of 7 and 1 is 7 distributed between the two parties. We say party, sine, party. Let each party be multiplied by the determined LCM. Thereby writing 7 times 22d out of 7 equals 7 times 110 centimeters. Then cancel by 7 or divide by 7 once, divide by 7 once. Remember 22D equals 7 times 110 centimeters. Then the next step, divide by 22. That's 22D divided by 22 equals 7 times 110 divided by 22 centimeters. By 22 ones by 22 ones, remaining the diameter, which is D, and now normally first divide by 11 for things concerning pi, especially when one uses 20 out of 7. So we say by 11, that's 20 divided by 11 is a 2, 11 divided by 11 is a 1, and a 0. So I've got 10 divided by 2. So by 2 ones and by 2 get 5. Thereby remaining diameter 7 times 5 centimeters, which 7 times 5 is 35 centimeter diameter. And therefore, the diameter is 35 centimeters. Therefore, somebody or one can find the diameter given the number of revolutions as well as the distance. And that is only reached when one knows how to apply circumference. So apply circumference, you will know the diameter of your car tire. Then we shall then go to number 4 example, which will help you apply circumference in life. What does it read therefore? It reads, a wire was wound around a cylindrical tin 2,000 tons. A wire was wound around a cylindrical tin 2,000 tons. If the tin had a diameter of 49 centimeters, find the length of the wire in meters. You have 4 strings wound around. To wind is to rotate something around a circular object. We are winding now. Teacher is winding. I'm winding. This is winding. Rotating something around something is winding. And the past simple is wound. Like you see find and say found, like wind and wound. Somebody may read wound. That's another thing. But this is winding, the verb to wind. Then opposite is rewind. If you want to use this wire, put it off through rewinding. If you want to keep it safely, you wind around a cylindrical object. Now, being that a cylindrical object is circular, then any time you wind like this, once like this, you will have applied circumference in life onto this object, thereby keeping your wire safely. So that's what's called winding. So a wire was wound around a cylindrical tin 2,000 tons. If the tin had a diameter of 49 centimeters, find the length of this wire, but in meters. As we have learned from the practical part, you say 1 ton wound or 1 time wound. 1 ton wound represents circumference. Which circumference we don't have? You say circumference called pi d. Circumference called pi times d. Then continue to substitute and say circumference called 22 out of 7 times 49 centimeters. And say by 7 ones 49 by 7. 7 thereby remaining 22 times 7 in centimeters. Then side work to multiply. You can as well call it part of work, but I've called it side work today. We say 2 times 7 or 7 times 2 is a 14, right? For group 1, 7 times 2 is a 14 plus the group 1 is 15. So circumference is 154 centimeters. You already want to examine that 1 time wound or 1 ton wound represents my circumference, and now the circumference is 154 centimeters. So 1 ton wound represents a 154 centimeter wire. So, but has been wound around 2,000 tons. So 2,000 tons, we take 2,000 times 154 centimeters. Then you side up 154 times 2. Remember to bring down the 3 zeros. So 154 times 2, 2 times 4 is 8. 2 times 5 is a 10, right? 0, group 1. So 2 times 1 is a 2 plus 1 is a 3. Thereby getting 308 and the 3 zeros. So 2 tons wound is a 308,000 centimeter wire. But the question asked you to to find the length of a wire in meters. Now, if you already got it in centimeters, convert centimeters to meters by knowing that by knowing that 100 centimeters make a meter. What about 308,000 centimeters? That is 308,000 divided by 100 meters. Cancel by 10 by 10 by 10, remain with 3,080 meter wire. So the whole wire is 3,080 meters long. So that's how someone can find the length of the wire given the number of times any string can be a wire, a rope has been wound around a cylindrical object. But what enables us to find this, that's knowledge of circumference applied in daily life. So that is, those are some of the examples on how one can apply circumference at school or after school. So you can add on other examples, but in this perspective, that is when you benefit from your school fees at home or after your home, wherever you go. I am teacher Katimbo Richard. If one wants to reach this same teacher Katimbo, one would call 0776251655 for more explanation. Otherwise, stay safe.